Hard drive. The hard disk drive was invented in 1956 by IBM engineers, revolutionizing how computers stored data. The first hard drive was the size of a refrigerator and could only store 5 megabytes. Today, hard drives can store up to 20 terabytes in a device that fits in your hand. They work by using spinning magnetic platters and a read-write head that hovers just nanometers above the surface. What makes hard drives powerful is their capacity and affordability. Companies like Seagate and Western Digital produce drives that store terabytes for under $100, making them perfect for media libraries and backups. They're still the go-to choice for network-attached storage and enterprise servers, where capacity matters more than speed. However, hard drives have significant limitations. Because they rely on mechanical moving parts, they're vulnerable to physical damage from drops or impacts. Hard drives are also much slower than SSDs, with read speeds around 100 to 200 megabytes per second compared to thousands. They consume more power, generate heat, and make noise. But despite these drawbacks, hard drives remain essential for bulk storage, where cost per gigabyte is the primary concern. SSD, solid-state drives, emerged in the late 2000s as a revolutionary alternative to traditional hard drives. Unlike hard drives, SSDs use flash memory chips with no moving parts. The technology became mainstream around 2010 when prices dropped enough for consumer adoption. Samsung, Intel, and other manufacturers transformed SSDs from expensive luxury items into standard computer components. What makes SSDs powerful is their incredible speed and reliability. Modern SSDs can read and write data at speeds exceeding 7,000 megabytes per second with NVMe technology, making boot times nearly instant. They're virtually silent, consume less power, and generate minimal heat. SSDs are also far more durable than hard drives, able to withstand drops and vibration without data loss. Upgrading from a hard drive to an SSD is often the single biggest improvement you can make to an old computer. However, SSDs have notable disadvantages. They're significantly more expensive per gigabyte than hard drives, making large-capacity SSDs prohibitively expensive. SSDs also have limited write cycles, meaning each memory cell wears out eventually. Data recovery from a failed SSD is more difficult and expensive compared to hard drives. But despite these limitations, SSDs have become the standard for operating system drives and applications where speed matters. Cloud storage evolved with the Internet, launching mainstream with Dropbox in 2008 and Google Drive in 2012. Instead of physical devices, cloud storage lets users access data from anywhere with Internet. Files are stored on massive server farms owned by Amazon, Google, and Microsoft. What makes cloud storage powerful is accessibility and convenience. You can access files from any device without carrying physical storage. It provides automatic backups, protecting against device failure. Services offer collaboration features for multiple people to work simultaneously. Cloud storage scales infinitely, and the redundancy means your data is stored in multiple locations for exceptional reliability. However, cloud storage has serious drawbacks. It requires ongoing monthly subscriptions, unlike buying physical storage once. You're completely dependent on internet connectivity, without which you can't access files. Privacy and security concerns are significant since you're trusting third parties with sensitive data. Upload and download speeds are limited by your internet connection. But despite these concerns, cloud storage has become essential for modern computing. Optical disc. Optical discs, including CDs, DVDs, and Blu-rays, became popular in the 1980s and 1990s. CDs were introduced in 1982 by Philips and Sony for music, then adapted for data. DVDs arrived in 1995 with higher capacity. These discs use lasers to read microscopic pits burned into the surface. What makes optical discs useful is their durability and portability. Properly stored discs can last decades without degradation, making them excellent for archival purposes. They're standardized. A DVD burned in 2005 still works today. They're cheap to manufacture in bulk and require no power to maintain data. However, optical discs have become largely obsolete. Capacity is severely limited. CDs hold only 700 megabytes, DVDs around 4.7 gigabytes, and Blu-rays max out around 100 gigabytes. They're extremely slow and physically fragile. Modern devices increasingly lack optical drives, and streaming services replaced physical media. But despite their decline, they remain relevant for specific archival purposes. USB drive. USB flash drives were introduced in 2000 by IBM and Trek Technology, becoming the most popular portable storage. These small devices use flash memory optimized for portability. They plug directly into USB ports, requiring no additional cables or power. Their convenience made them instantly popular, replacing floppy disks overnight. What makes USB drives powerful is their portability and convenience. They're small enough for a keychain, yet store hundreds of gigabytes. They work on virtually any computer without installing drivers. True plug-and-play functionality. They're perfect for transferring files, carrying presentations, or creating bootable media. Modern USB drives with USB 3.0 offer decent transfer speeds for large files. However, USB drives have significant limitations. They're easy to lose due to their small size, and most aren't encrypted by default. The connector can break with repeated use. Performance varies wildly between models, with budget drives being frustratingly slow. They're also vulnerable to malware, but despite these issues, USB drives remain ubiquitous for quick file transfers. Memory card. Memory cards evolved from PC cards in the 1990s, with SD cards introduced in 1999 by SanDisk, Panasonic, and Toshiba. These tiny cards use flash memory designed for portable devices like cameras and phones. Formats include SD, micro SD, and compact flash, each optimized for different devices. What makes memory cards powerful is their specialized design. Micro SD cards are barely larger than a fingernail, yet store over a terabyte. They handle camera demands with fast write speeds for photo bursts and 4K video. They're hot swappable and have become the standard for expanding smartphone storage. However, memory cards have notable drawbacks. Their tiny size makes them easy to lose, and contacts are prone to corrosion. Speed varies dramatically between cards. Fake memory cards are rampant with counterfeit products that fail prematurely. But despite these limitations, memory cards remain essential for portable devices. Floppy disk. The floppy disk was invented in 1967 by IBM for loading mainframe microcode. The 3.5-inch disk became standard in 1982, storing data magnetically on flexible plastic enclosed in a protective case. For decades, floppies were the primary way to distribute software and share files. What made floppy disks revolutionary was their portability and standardization. They could move data between any compatible computer. They were cheap to manufacture, making them perfect for software distribution. They required no power to retain data, and every computer from the 1980s through early 2000s included a floppy drive. However, floppy disks had severe limitations that led to their extinction. Capacity was only 1.44 megabytes, barely enough for a single photo today. They were fragile, vulnerable to magnetic fields, dust, and moisture. As software grew larger, requiring dozens of floppies became absurd. By the mid-2000s, CD-ROMs and USB drives completely replaced them. Today, floppy disks exist only as the universal save icon. Magnetic tape. Magnetic tape for data storage dates back to 1951, when UNIVAC I used it for the first time in commercial computers. Data is written sequentially along the tape using magnetic read-write heads. While this sounds ancient, modern tape drives are still used extensively by enterprises and research institutions for long-term archival. What makes magnetic tape powerful is its unmatched capacity and longevity. Modern LTO-9 cartridges store up to 18 terabytes of uncompressed data. The cost per terabyte is the lowest of any storage technology, making tape perfect for massive amounts of data that doesn't need frequent access. Properly stored tapes last 30 years or more. Major companies and film studios use tape to archive petabytes of data. However, magnetic tape has major disadvantages for everyday use. The biggest problem is sequential access. To read data from the middle, you must fast forward through everything before it, making random access incredibly slow. Tape drives are expensive initially, and the technology requires specialized knowledge. But despite these limitations, magnetic tape remains the gold standard for cold storage and long-term data preservation worldwide. Yo tech nerds, watch this video next, and don't forget to subscribe as well.